Gravity is an invisible force that holds the entire universe together. But what if, one day, it simply vanished? Gravity is the fundamental force that keeps our feet on the ground, holds the planets in orbit, and gives structure to the cosmos. It's always present, yet we rarely think about it. Without gravity, everything we know would be drastically different, or perhaps wouldn't exist at all. Imagine a force that is everywhere, yet you cannot see, touch, or hear it. Like an unseen hand, gravity controls the movement of everything around us. In many ways, it resembles magic, a silent, powerful spell that binds the universe together. But unlike magic, gravity follows precise physical laws. But what if, in an instant, this force was no more? What if gravity simply disappeared? Prepare yourself, as today we venture into a world where gravity ceases to exist. Gravity is not just a force, but a curvature of space-time. According to my theory of relativity, gravity is not a conventional force in the classical sense. It occurs because massive objects warp the fabric of space-time around them, and other objects entering this curved space move along the resulting paths. For instance, Earth falls into this curved space-time, creating its orbit around the Sun. Gravity is the only force that acts over vast distances. Unlike the electromagnetic and weak nuclear forces, which operate at incredibly small scales, gravity pulls objects together across distances that shape the structure of the entire universe. Without gravity, there would be no planets, stars, or galaxies, just an empty void. Gravity affects time itself. My theory of general relativity tells us that gravity can slow down time. The stronger the gravitational field, the slower time moves. This has been confirmed through experiments with atomic clocks, showing that time passes faster at higher altitudes compared to sea level. If gravity disappeared, Earth would immediately leave its orbit. Without the gravitational pull of the Sun to keep us in place, Earth would no longer be bound to its orbit. In a matter of hours, it would drift aimlessly through space, leaving life as we know it unsustainable. The disappearance of gravity would mark the end of our stable existence. Gravity is weaker than the other fundamental forces. Despite its dominance on a cosmic scale, gravity is actually the weakest of the four known fundamental forces. The electromagnetic force, which binds atoms and molecules, is approximately 10 or 36 times stronger than gravity. Gravity can be negative. In some theories, like those involving dark energy, it is suggested that there may be a form of gravity that repels rather than attracts. This idea helps explain the accelerating expansion of the universe. If negative gravity existed, it would create an anti-gravity effect, pushing objects apart and disrupting the usual behavior we observe. Without gravity, humans would become sky travelers. In a world without gravity, people and objects would begin to levitate. Without gravity's pull, we would lose the ability to remain grounded and move around in a familiar way. The only force left would be inertia, and humans and objects would float aimlessly through space unless they encountered something to stop them. Gravity is responsible for ocean tides. The moon and the sun exert gravitational forces on Earth, causing the rise and fall of ocean levels. The moon, being much closer to Earth, has the strongest influence, while the sun's gravity, despite its massive size, has a lesser effect due to its greater distance. Gravity and space debris. Since gravity pulls everything toward it, space debris is no exception. Satellites and fragments from old rockets don't remain in space indefinitely. Over time, gravity brings them closer to Earth, and eventually they re-enter the atmosphere, where they burn up. Gravity and black holes. Perhaps the most extreme manifestation of gravity is the black hole, regions of space where gravity is so intense that even light cannot escape. These entities consume matter and energy, creating a phenomenon that is as mysterious as it is terrifying. Now, imagine that suddenly, gravity is gone. Completely. What happens next? First seconds. Chaos begins. The moment gravity disappears, the world as we know it is thrown into chaos. People, animals, and objects start floating. Since nothing is being pulled toward the Earth anymore, everything that isn't physically attached to the ground begins drifting. Imagine walking down the street and suddenly finding yourself weightless, tumbling helplessly into the air. Atmosphere detaches from the planet. Our air is held in place by gravity. Without it, the atmosphere has nothing keeping it close to the Earth's surface. The air rapidly begins escaping into space, creating hurricane-force winds as it rushes outward. Breathing immediately becomes difficult. Vehicles, trees, and loose objects lift off. Cars, bicycles, and even entire trees uproot and start floating unpredictably. People indoors might be momentarily safe, but they too will soon be affected. As time progresses, the destruction escalates beyond anything humanity has ever witnessed. Oceans and rivers leave the Earth. Water, like air, is held in place by gravity. Without it, the world's oceans no longer stay on the planet's surface. The seas begin rising in massive, uncontrollable waves that spread out in all directions. Imagine billions of tons of water lifting off, forming colossal globules that start breaking apart as they escape into space. Buildings collapse. The materials that make up buildings, concrete, steel, and glass, are engineered to withstand gravity. With that force gone, structural integrity is lost. Skyscrapers, bridges, and towers begin crumbling or floating apart, leaving behind chaotic debris fields. Planes and spacecraft lose control. Airplanes, which rely on aerodynamic lift, become useless without gravity regulating their flight. Pilots lose control as their aircraft begin drifting aimlessly. Space stations and satellites, though already in microgravity, might be flung off course by atmospheric disturbances. 1 hour later, oxygen runs out. An hour after gravity's disappearance, the situation becomes even more dire. No more breathable air. With the atmosphere gone, oxygen levels plummet. Most people, animals, and plants suffocate within a matter of minutes. Those inside sealed environments, such as submarines or deep underground bunkers, might survive a little longer. The Earth loses its orbital path. The planet was moving at approximately 107,000 kilometers per hour, which is about 66,000 miles per hour, around the Sun due to gravity. Now, with no force keeping it in place, it no longer follows its stable orbit. Instead, Earth begins drifting aimlessly through space, at the mercy of external gravitational influences. Long-term consequences. A lifeless planet. As time passes, the consequences become irreversible. The Earth is ejected from the solar system. Without the Sun's gravitational pull, Earth continues traveling in a straight line into deep space. Over the coming years, it moves farther and farther away from the warmth of the Sun. Temperatures drop to extreme lows. With no sunlight, the surface of the planet freezes. Temperatures plummet below -200 degrees Celsius, which is minus 328 degrees Fahrenheit, making Earth resemble a lifeless ice world. Complete extinction of life. Any life forms that survived the initial catastrophe, perhaps deep-sea creatures or microbes underground, eventually perish as the planet becomes a frozen wasteland. Could there be a place in the universe where gravity does not exist? Weightlessness in space. A gravity-free illusion. In space, astronauts experience what is often called zero gravity, but in reality, gravity is still present. It is just weaker. Objects in orbit, like the International Space Station, are constantly falling toward Earth, but because they move so fast, they never actually hit the surface. This creates the sensation of floating, which is what we call microgravity. However, true zero gravity does not naturally exist anywhere in the universe. Even in the vast emptiness between galaxies, there is always some tiny amount of gravitational pull from distant objects. This means that no place in the cosmos is completely free from gravity. Can we create artificial gravity? If we cannot escape gravity entirely, can we at least control it? Scientists and engineers have proposed several ways to create artificial gravity, which could be essential for long-term space travel. Rotating space stations. By spinning a spacecraft or space station, centrifugal force can simulate the effects of gravity. The faster it spins, the stronger the force pushing objects toward the outer walls, creating an experience similar to standing on Earth. Magnetic levitation. Some experiments have shown that strong magnetic fields can make certain objects, even living organisms, float in midair. While this is not true gravity, it could be used to counteract weightlessness in space. Future technologies. Some theoretical ideas involve manipulating gravity using exotic matter or energy fields. While this remains purely speculative, future breakthroughs in physics may one day allow us to control gravity just as we manipulate electricity today. The future of humanity in microgravity. As humans prepare to expand beyond Earth, adapting to life in low-gravity environments will become a necessity. Orbital space stations, future space habitats, could be designed with rotating sections to provide artificial gravity, reducing the negative effects of weightlessness on the human body, such as muscle loss and bone deterioration. Colonies on Mars and the Moon. Mars has only about 1/3 of Earth's gravity, and the Moon has even less. Future settlers may need to develop technologies to counteract the health risks associated with living in weaker gravitational fields. Long-term space travel. If humans ever travel to distant stars, they may need artificial gravity systems inside their spacecraft to maintain their health and daily routines over extended missions. A world completely without gravity does not exist in nature, but humans are learning to adapt to low-gravity environments. With advances in technology, we may one day control gravity itself, paving the way for a future where humanity thrives beyond Earth. From rotating space stations to potential colonies on Mars, the challenge of living without Earth's gravity pushes the boundaries of science and human exploration. Gravity has shaped our past and present, but could mastering it define our future? If you enjoyed this journey into the mysteries of gravity, make sure to subscribe to the channel and turn on notifications. There are many more fascinating scientific questions waiting to be explored, so stay curious and keep asking.